Welcome to this lesson on half-life and radioactive decay time. Half-life is one of the most important concepts in nuclear physics and has numerous real-world applications. In this video, you'll learn what half-life means, how to calculate it, and where it's used in everyday life. Half-life is defined as the time required for half of the radioactive nuclei in a sample to undergo decay. When radioactive atoms are unstable, they spontaneously break down over time, releasing radiation in the process. The half-life tells us how long it takes for exactly half of these unstable atoms to transform into more stable atoms. Half-life has three important characteristics. First, it is constant for each radioactive isotope. This means that carbon-14, for example, always has the same half-life regardless of where or when you measure it. Second, the half-life is independent of the initial amount of the substance. Whether you start with 1 gram or 1,000 grams, the half-life remains the same. Finally, radioactive decay follows an exponential decay pattern, which means the quantity decreases by the same fraction during each equal time period. Let's visualize how radioactive decay works over time. If we start with 100% of a radioactive sample, after one half-life has passed, only 50% of the original sample remains. After two half-lives, we're left with 25%. Notice that the amount doesn't decrease linearly, but rather by half each time. This is the essence of exponential decay. The mathematical formula for calculating remaining quantity uses exponential decay. N of t equals n naught times 1/2 raised to the power of t divided by t sub 1/2. Here, n of t represents the remaining quantity at time t, n naught is the initial quantity we started with. T is the time that has elapsed, and t sub 1/2 is the half-life period of that particular isotope. Let's work through a practical example. Suppose a sample contains 100 grams of carbon-14. We want to know how much remains after 11,460 years. The given information includes the initial amount n naught equals 100 grams, the half-life of carbon-14 equals 5,730 years, and the time elapsed equals 11,460 years. Now let's solve this step by step. We start with the formula. N of t equals n naught times 1/2 raised to the power of t divided by t sub 1/2. Substituting our values, we get n of 11,460 equals 100 times 1/2 raised to the power of 11,460 divided by 5,730. This simplifies to 100 times 1/2 squared, which equals 100 times 1/4, giving us 25 grams as our final answer. Half-life has many important real-world applications. In archaeology, carbon dating uses the half-life of carbon-14 to determine the age of ancient artifacts and fossils. In medicine, radioactive tracers with specific half-lives are used in diagnostic imaging procedures. Nuclear power plants must carefully manage radioactive fuel and waste based on their half-lives. And in geology, scientists use the half-life of various isotopes to date rocks and determine the age of Earth's formation. Understanding half-life is essential for all these fields.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.